2.1 is all about solving different types of equations. So I'm just going to start right in on solving for x. You notice that there's a 5/3 x and a 2/3 x, and you have to bring them over to the same side. I like bringing all my variables over to the left side, so I'm going to subtract 2/3 x to both sides. 5/3 x, take away 2/3 x is 3/3 x, and 3/3 x is just a 1x equals 4. So x equals 5. Okay, the second problem. If you have a fraction equals a fraction, it's called a proportion. And how do you solve that? Is by cross multiplying. You have to take 3 and multiply it by 3x plus 1. You have to use the famous distributive property to solve for it. 3 times 3x is 9x. 3 times 1 is 3. You also have to use the distributive property when you multiply 7x minus 2 times 9. You get 63x minus 18. Now you have to bring the x's together on one side, and I'm going to bring this over to this side by subtracting 63x, which gives you a negative 54x plus 3 equals a negative 18. Negative 54x has to equal a negative 21. Divide both sides by a negative 54. X is going to equal a positive, 3 goes into both of those, 7/18. Okay, next problem. 2/5 plus 4 over 10x plus 5 is equal to 7 over 2x plus 1. This again is chapter 9 in the Algebra 2 book. The first thing you want to do is put these two together. You cannot add two fractions together until you find a common denominator. So the first thing I'm going to do is take out the GCF on this denominator. 10x plus 5 has a 5 in common. You're going to have a 2x plus 1. So your common denominator on the left-hand side is a 5 and a 2x plus 1, and a 5 and a 2x plus 1. I cannot add these two fractions together until I find a common denominator. Look at this old denominator and look at the new denominator. What is the difference between the old one and the new one? Doesn't the 2 need to be multiplied by 2x plus 1? And I know I did it right, because if I cancel out 2x plus 1 on the top and the bottom, I'm back to what it looks like. This one I don't have to do anything to it, and I'm just going to copy this side down. Now that I have a common denominator, I can write it under one denominator. I'm going to do the distributive property, so I get 4x plus 2 plus 4 equals 7 over 2x plus 1. I'm going to have a 4x plus 6 on the top, and I'm going to have a 5 parentheses 2x plus 1 on the bottom equals 7 over 2x plus 1. Now that I have a fraction equals a fraction, I can cross multiply. Your Algebra 2 teacher taught you something when we did proportions last year. If both denominators have the same thing, do you notice that they both have a 2x plus 1? Whatever you do to one side of the equal sign, you have to do to the other. Since they're both in the denominator, if you take away one side, you can also take away the other side. So there's only a 1 left, which makes it way easier. Now when you cross multiply, 4x plus 6 times 1 is just 4x plus 6. You only have 5 times 7 on the other side, which is 35. So that'll save you some time if you remember that from Algebra 2 last year. Subtract 6, you're going to get 4x is equal to 29. x is equal to 29/4. You can write it as a fraction, you can write it as a decimal, it doesn't matter. You can see that in college algebra, all the answers are not turning out nicely. That's what happens when you get into a higher level math class. You're supposed to just prove this identity in part 2. Prove the identity. This is similar to what you had in the last chapter. You need to notice that the top is a difference of 2 perfect squares. You can put a 7x on the left and a 7x on the left. You can put a 5 on the right and a 5 on the right because those are 2 perfect squares with a plus and a minus with a 7x minus 5 on the bottom. You have the same on the top and on the bottom, and they do equal the 7x plus 5. You're just proving that the left side looks like the right side. That's all you're doing for part 2. Okay, part 3 is, I think, might be the last section. I think we have another page, but yeah, this is the last section. You know that y is equal to mx plus b. This is called the slope-intercept formula for a line. You usually see it in the form of y. What they want you to do is they don't want you to solve for y, they want you to solve for x instead. So I'm just going to come over here. Oh no, let's do this instead. If you want to get x alone, when you add 4 to both sides, which gives you 2x equals 12, and divide by 2, x equals 6. It's the same concept. You're asking to solve for x. They're doing the exact same thing here. They're asking you to solve for x. So you have to still use your same operations, except there are numbers in this problem, and there's only letters in this problem. You still can subtract b to both sides. So you have y minus b equals mx. And then you're going to divide both sides by m in order to get x alone. Final answer, x is equal to y minus b over m. This is a very important section. You'll see this on the ACT. They're expecting you to rearrange your formulas into different variables. You have an EK plus L equals D minus TK. They want you to get that letter alone. They want you to get K alone in this problem. So this one's a little bit more challenging than the first one. Well, the first thing I'm going to do is put the EK and the TK together on the same side. By adding TK to both sides, I can bring the negative TK over to the left. I'm going to leave the D on the right side, and I'm going to bring the L over. If I bring the L over, it's going to end up being a negative L. Everybody see what I did? I just switched the L to the right, and I brought the negative 2K over to the left. I'm trying to get K alone. Again, you have to know your algebraic factoring skills. These two have something in common with each other. What do they have in common with each other? Yes, they have the letter K in common, which is called the greatest common factor. I can take out the K, then that one's going to only have an E left, plus the T left equals D minus L. I still have to get K alone. I need to divide both sides by E plus T. K then is equal to D minus L over E plus T. Okay, I think we have one more. S is equal to 1/2 GT squared plus V sub 0 T. This is a physics formula. These are all just different formulas either in science or in math that you need to be able to rearrange them depending on which letter or variable that they want you to get alone. Right now the S is alone. They want you to get V sub 0 alone. So the first thing I'm going to do is subtract 1/2 GT squared to both sides. So the first thing I did was subtract 1/2 gt squared to the left side. The whole thing is to try to get v sub 0 alone. All I have to do is divide both sides by t. Goodbye to the t's. And in just a couple of steps, I got v sub 0 alone. That's all the notes for 2.1.